Okay, in this video we are going to attempt question 10 of paper 2 in the SPM at Maths 2019 exam. Right, first you're required to prove this specific identity. Okay, that's pretty straightforward. Then you're going to sketch out this graph, which is simply a sine curve, and hence using the same axis, sketch a suitable straight line to find the number of solutions for this equation. Okay, so you can see immediately that cotangent A over 2 and everything is simply the right hand side of that equation rearranged with sine A on the other side. Okay, looks pretty straightforward. Let's give this a go. Okay, I'm going to snap that to the left and snap this to the right, so we've got the question right there. So we have to prove that tangent A over 2 is equals to well, that expression. So if you simply rewrite that, let x equal to, what do we have? 2a, a over 2, right? We can simply rewrite that to something a lot more familiar, which is that tangent x is equals to 1 minus cosine 2x divided by sine 2x. Alright, and the examiners have even very helpfully given you the formula for that. So cosine 2x is 1 minus 2 sine squared x. Oh dear. Okay, let's just get rid of that. Okay, so 1 minus 2 sine squared x divided by sine 2x is simply, where did I see that? Oh, here we go. 2 sine x cos x. Sine x cosine x. Alright. So 1 minus 1 is 0. That leaves you 2 sine squared x divided by 2 sine x cos x. Eliminate the square, eliminate 2. That leaves you sine x over cos x, which is tangent x, well, equals to tangent x. Right? Well, obviously you've got to rewrite this. Now you say that, hey, the right hand side is equal to this. The right hand side is equal to this, and work it out and show that it's equal to the tangent x, which is the left hand side. But anyway, I'm just taking shortcuts here. That proves the identity. Okay, let's go back to question. What was that? 10. Right. So question 10, A1. Done. Hence, without using a calculator, find the value of tangent 15 degrees. That's easy. So A2. You're simply substituting, you know what, let me just give you a darker line. Alright, so tangent 15 degrees is simply equals to 1 minus cos of 30 divide sine of 30. Alright, and obviously if you've been studying at maths, cos 30 and sine 30 should be pretty easy. But if you're panicking in the middle of an exam and you don't know what they are, just draw a equilateral triangle, 60 degrees everywhere. Right, draw a straight line, so that's 30 degrees right there. Sides of 2 each, so with the Pythagoras theorem, that's obviously root 3. So cos 30 is root 3 over 2, and sine 30 is 1 over 2. Alright, multiply 2 on both sides, that's your answer. Okay, section 2 done. Can't believe they gave us 4 marks for just that. Right, sketch the graph of y equals minus blah, 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 minus 3 over 2 sine A for that region. Okay. Nothing too tricky, just got to watch out for the minus sign and the fact that it's scaled by 3 over 2. So let's attempt that. Put this away. Let's give us a bit more room. How's that? You know what, I think I've got to get a new screen, so here we go, clear the canvas, done. Okay, so that's, thankfully there's lines on my screen here, so that's always handy. Okay, what's not so handy is my ability to draw straight lines. Okay, but never mind. Let's draw that. Okay, so let's call this pi over 2 and pi and 3 pi over 2 and 2 pi. Okay, it's easy enough. Let's draw 2 points here, and we'll start by sketching, sine as we know it. So at 30 degrees, so let's assume this is minus half and minus 1, right? So this is 90 degrees. At 30 degrees, we know that the sine curve is half. At 90 degrees, we know it's 1, but because we're sketching a negative sign, which is negative 3 over 2, we just flip the sine curve, right? So we just join the dots basically. We've got that at 3 pi over 2, and that, okay? So now we join that with your steadiest possible hand. I remember my maths teacher had this uncanny ability to draw beautiful, flawless sine curves and circles on the blackboard. It was amazing. Okay, so obviously I'm not my maths teacher, but anyway, you get the point. That's y equals minus sine A, right? But of course we're asked to scale it to, minus 3 over 2 sine A. So that's your A axis, and that's your y axis. So let's call this 3 over 2. So that's obviously 3/4. That's obviously 3/4, and obviously 3 over 2. And that's 3/4. That obviously is 1, and that's obviously minus 1. Okay, easy enough. All right, so that's section. What was that? Section B1 done, and hence using the same axes, sketch a suitable straight line. Blah blah blah. Okay. Let's throw that to the left and put this on the right. Okay. Hence, using the same axis, sketch a suitable straight line to find number of solutions for that. Okay. So now we know that this side, the left-hand side of this expression, this equation, is simply sine A. Okay. So we have, okay, the left-hand side. If we draw a graph that says y equals, what are we doing here? Minus 3 over 2 of sine A. So we've got this graph. If we rearrange that, cotangent A over 2, okay, of 1, put a big bracket out there, 1 minus cosine A, okay, we know that that is equal to sine A, right, from the previous excuse me, from the previous section, right? So what we need to do is to find a graph. Let me see, y equals minus 3 over 2 sine A. So we need to plot a graph that equates sine A to minus A over 2 pi. Okay. Now we don't have this graph, but we do have another graph. We have this graph. Simply need to plot this graph, which is y equals 3a over 4 pi. Okay. So what is 3a over 4 pi? So remember, we have a-axis against the y-axis, so you can think of this as the x-axis. Okay, that's sorry, the a y equals mx plus c type curve, and your what do I call it? Gradient is simply 3 over 4 pi. Let me have a look at that again. Okay. So your gradient is simply 3 over 4 pi, right? So you're going to have a straight line, something like that, crossing the origin at 0. Well, crossing the origin, I mean. And so we've got to determine 3 over 4, 3/4 divided by pi. Here we go. So if we put a dot over here, and if we draw a line over here, what's the gradient of this line? So we've got the distance, which is 3/4, divided by that horizontal distance, which is pi. So the gradient is actually 3/4 over pi. So that's your straight line right there. Ta-da! Okay. My line's not very straight, but obviously you're going to be using a ruler in the exam. Okay. So the number of solutions, which is the what the question wants, doesn't actually want you to find the solution. You just need to state the number of solutions. All right, from 0 to 2 pi inclusive. So these are the little tricks. You can see that crossing, that crossing. So there's 2 solutions, but that's also 1 solution right there. So there's a little trick there. So the answer is 3 solutions. Okay. That's it. Done.